Good evening, everyone. I welcome you all to the week 12 live session of Bioinformatics Algorithms and Applications course. So, today I'll be completing the remaining part of regression followed by that explanation of Veka. So, before moving on to today's main discussion, if any one of you have any doubts and wanted to discuss with the Professor Michael Gromia, who is the course instructor, do let me know. I can request him to join around at 7 p.m. today. So this will be the last session. I hope so. Other TAs have completed. So this will be the last session for the year 2024. Okay, I hope nobody replied. So I'll start with the regression. So last time we have discussed about the machine learning models, so of which we started with the first class of machine learning models, that is supervised machine learning models. Now, and apart from that, last time we have also covered about classification model. Now we are tackling about the regression. So regression is a type of supervised learning problem where the goal is to predict the continuous output based on a set of input features. So here in classification, we try to predict whether the data will belong to particular class, like whether the data is from class A or class B. Here we are predicting a real value problem. So in regression, the algorithm learns from the labeled data. So why we are calling it a supervised learning algorithm to predict the value of a dependent variable based on the values of one or more independent variables. So there are several types of regression problems, each with its own characteristics and algorithms. So when we talk about the data, a regression dataset is a collection of data used for regression analysis in machine learning. So in general, a dataset has input variables, or we call them input features, and output variable. Here in regression, the input variables are used to predict the output variable. The input variables are also called as independent variable or features, while the output variable is also called the dependent variable or target. The regression dataset can be divided into two parts, that is training and testing. So what happens on training dataset is the model learns the information from training data and then applies it to testing data. So this application on testing data helps to validate our model, how well our model is trained to predict. In generally 70, if you have 100 data points, 70 is to 30 ratio, 80 is to 20 ratio, kind of train test split is being performed. Here the purpose of testing data is to evaluate the performance of the model. So as we discussed, regression problems involve predicting a continuous output variable based on one or more input variables. So to build a regression model, it is important to select the input variables or features that are relevant to the output variable. Feature extraction and selection are the two main important techniques that are used in machine learning to identify the most important features. For example, what is feature selection or feature extraction? So when we are working with a particular problem or a particular prediction problem, for example, I want to predict how is the weather tomorrow or the next week is going to be. So to predict that and make the machine learn, I should use features that are related to weather. So I can't use uh, in any feature that is related to exams or other. I should use, okay, today, based on today's temperature, what will be the temperature tomorrow. So the feature selection is a very important aspect where a large studies on machine learning model include new feature generation as well as a combination of feature selections. So coming about the feature extraction. Feature extraction. So feature extraction is the process of transforming raw data into set of meaningful features that can be used for machine learning. So this feature extraction involves identifying the relevant pattern or relation in the data and extracting the features that can capture those patterns. For example, when we take any medical data set or any disease data set, feature extraction might involve identifying the important biomarkers that are indicative of a particular disease. Then feature selection. So feature selection is process of selecting a subset of available features that are more relevant to the output variable. So here feature selection, we'll be seeing how the feature selection could be performed in Veka environment. We have several methods of feature extraction and selection, that is principal component analysis. So this principal component analysis can be used to identify the most important features in the data and reduce the computational complexity of the regression model. Then we have correlation based removal. So what correlation tells is correlation analysis helps identify the most relevant features and eliminate the irrelevant ones. Like either the correlation value towards -1 or 1 are termed to be the important features in building a model. Then we have regularization. That is, to each feature we add a penalty term. So what this penalty term does is the role of a penalty term, or we multiply, add sometimes, so that we discourage overfitting or underfitting of a model. Then we have recursive feature elimination. So the before three steps could be performed only if we have knowledge about features. What if we have no knowledge about the features? Then we have recursive feature elimination. What it does is it will remove each feature and find its importance, whether the model performance is improving or not. So this is how a recursive feature elimination tells about the feature importance. Okay, before moving on to this, I want to announce it again. So if this will be the last class for this 2024 session. So if someone wants to discuss any doubt regarding this, I can request Professor Michael Gromia, who is the course instructor for this Bioinformatics Applications Algorithms course, to join at 7. Yeah, I'm announcing this again as new people join. Okay, so we have several types of regression techniques that are available. Like, right, if you remember our school time mathematics or anything, we used to have quadratic equations, polynomial equations, linear equations. So similarly, regression also has similar terminology to use. So first is linear regression. So we all know the general definition of a line y equals to mx plus c. So which has one independent variable corresponding to a dependent variable y. So this is a pattern of linear regression, simple linear regression. That is, this models the relationship between input variable, like single input variable and output variable. So the goal of this simple linear regression is to find a best fit line that maximizes the distance between the predicted values and the actual values. Similarly, we have multiple linear regression. So what is difference between multiple linear regression and single linear regression is we have n number of variables that are available in multiple linear regression. So here the equation becomes y equals to m1 x1 plus m2 x2 plus m3 x3, so on. Then we have polynomial regression. So here the polynomial regression is useful, is kind of a non-linear way of modeling the data. So here the terms like x1 square, x2, x1 cube, x2 square are being used. So the equation, the model equation or the example equation can be y equals to m1 x1 square plus m2 x2 square, like that. Then we have several other techniques. So each of these techniques has its own strength and weakness. and there are some metrics to measure. So now that how to tell our model is performing good or bad. So here are some common validation metrics in regression that we use. So first one is mean square error, shortly written as MSE. So which is the average of squared differences between predicted values and actual values of the output variable. So it is widely used metric in regression and it is sensitive to outliers. Then we have root mean square error. So root mean square error is the square root of MSE and is also widely used. So one can ask a question, why we need MSE as well as RMSE. So when we validate our models, if I tell my model is predicting a value, so if I want to predict a value which is 6 and my model is predicting it as 7, the deviation is only 1 unit. But when we take on a scale of 1 to 10, the value of 1 is so high. But when we are trying to predict values such as what is the temperature or what could be the gold rate today and all, the unit of 1 is so small. So when we are dealing with the higher order numbers or higher order prediction problems, RMSE and MSE are used. While when we are dealing with the small numbers, orders of 1 or within 2-digit numbers, we use mean absolute error. So which is the average of absolute differences between the predicted values and actual values of the output variable. Then we have R square that measures the proportion of variance in the output variable that is explained by regression model. Then sometimes this R square has updated term which is adjusted R square, which is a modified version of R square that takes into account the number of input variables in the model. So here I have some of the questions. Do try to answer them one by one in the chat box. After this, we will be moving on to the Veka session. Okay, so the first question starts here is, what is the purpose of regression analysis? Whether it's to measure the correlation between the two variables, or to predict the dependent variable on one or more independent variables, or to identify outliers in data set, and to calculate mean and standard deviation of the data set. Yeah, the first one is B. So when we try to answer in MCQs, always it be sure to give the most appropriate answer as the here. So in regression analysis, correlation is also part. We measure a correlation between two variables, but we don't do regression analysis to measure the correlation. But correlation is used to assess the performance of regression models. And what happens with option C is, we identify outliers and then remove these outliers in regression data so that the model performance can be improved. Okay, now that we have the second question, which is, what is the difference between simple linear regression and multiple linear regression? Thank you. I request others also to answer. So whether single linear regression has only single variable, independent variable, that is single x, and while multiple regression is having more than one independent variable. Whereas simple linear regression has only one dependent variable, while multiple linear regression has only one dependent variable. Yeah, so in single linear regression, we have only one independent variable, that is x. So the general terminology is y equals to mx plus c. Whereas in multiple linear regression, we have more than one independent variable. The equation can be written as y equals to m1 x1 plus m2 x2, so on like that. Finally, the question is, which type of regression analysis could be used for predicting the binary outcomes? That is, do we have any regression kind of model that can use for a classification problem? Yeah, so we have logistic regression. Okay, so before to start with Veka demo, here we'll be talking about how Veka has been developed, where. So Veka stands for Waikato Environment for Knowledge Analysis, and is a open source data mining tool that provides a GUI graphical user interface for users to apply various machine learning algorithms to a data set. The major question that comes in the mind of a biotechnology or a biologist is, can we learn really to write a code or and apply our machine learning models? So here Wake provides a GA graphical user interface. The purpose of graphical interface is everything is coded in the backend. Just the graphical user interface works on clicking. Just you click this. If you tell the Weka to do a regression analysis, it will do. If you ask Weka to build a neural network, it will build. So this is the purpose of the graphical user interface here. So it is developed at the University of Waikato in New Zealand, and it is available under general public license. So it is available free to download. So Weka provides a wide range of tools and algorithms for data pre-processing, classification, regression, clustering, association rules, data mining, and several other tools. So how should we prepare the input into the Weka? So we use either CSV format or ARIFF format, which is a default format from Weka. So first, when you install Weka, I'll show how to install also. So when you install Weka, you will see this Weka graphical user interface chooser. So you can select the Explorer. So Weka Explorer, one can select the Weka Explorer, which is a graphical user interface of Weka tool that allows users to perform several tasks. This Explorer again contains several subtabs that provide access to different functionalities of the tool. So in the pre-process tab, if we observe, so here is the pre-process tab. So under the pre-process tab, so you can include open your file, open a URL dataset from file, URL or a database. Then under that, side to the pre-process tab, you can see classify tab. So classify tab is the place where several machine learning algorithms have been available. So you can select one and then proceed to it. Then we have cluster tab. This is for performing clustering methods such as k-means clustering, hierarchical clustering. Then we have associate tab, select attributes tab here. So associate tab is to mine association rules. So it's for identifying patterns or relationship between the different attributes. Then we have select attributes. So in the start of the class, we have discussed about feature selection and feature extraction. So select attributes does that. Next we have visualize tab. So where we can see the correlation plots between the data set. So now we'll start with the classify tab. So in the pre-process tab, you load your data, then you move on to classify tab. So in the classify tab, first option you see is a classifier. So here you can select the several algorithms which are available. So here I am showing you how a classified tab looks. So the first is classified. Under the classified option, several algorithms, machine learning algorithms have been pre-coded and kept. So here for example it is showing 0R method selected. Under this we have test option. So how to test the performance of a model, whether you want to test your performance of your model on your training set, or you have any external supplied test set, or you want to perform cross validation, or you want to perform percentage split, then you can click start for the model to develop. Here in the right hand side I am showing how to visualize the correlation between the features and the output variable. So this is for a binary classification problem. So you can see here two classes have been separated equally. Okay, sorry for interruption, give me a second. Yeah, so here I wanted to get your notice. If someone wants to discuss with Professor Michael Gromia, who is the course instructor, so if you can inform me now, I can inform him so that he can join the session by 7 p.m. the same session. Yeah, do let me know before in 5 minutes so that I can inform him he'll be prepared. So, how to load the data, how data sets are provided will be shown. So, first is here clicking on open file, you can load your data set. So, Veka has some sample data sets which is common, every machine learning method has those. So, if someone wants to know about more machine learning problems or more machine learning data sets, kaggle.com is available. So in the Google you can type Kaggle and you can see several data sets and several machine learning problems that are given for common man practice purpose. So once I load my data into the pre-process tab, you can see the information about the data that is provided here. You can see what are the individual classes we have, number of attributes, so number of attributes and number of columns in the CSV file that we input, instances here, so number of instances are number of rows that we input. So these are the several machine learning algorithms that are available. So what Veka does is, based on your problem, or what, whether you want to do a classification problem or you want to do a regression problem, it will automatically select the methods that can best suited for your data set. So when you observe closely in this image, the M5 rules has been masked. What this means is that this method is not suitable for your data set. If your method is suitable for your data set, it will be shown in a black. Then we have different types of validation, that is use training set, supply test set. So what happens in use training set is the, the regression model will be trained on the same data set and be tested on the same data set. Okay, so the major concept that we are learning is feature selection. So in Veka, we have select attributes tab in the top. So here you have select attributes. So if your data set is having n number of features and you don't want to use all of them, we can use attribute selection. So what does this attribute selection does is identifies the most relevant subset of features or attributes from a dataset that can best represent the underlying patterns and relationships. So here we have search method and evaluation method. So search method tries to find all the combinations of data sets, all feature combinations, and evaluation method tells us which combination is better to use. We'll see how that's done. Okay, give me a minute. I'll open my Weka and I'll show. Yeah, just give me a minute. I'll open. So here in the Google search, one can type Weka, enter. So here you can see from the source forge, Weka is available. So Weka is available for all Mac systems, Windows systems, as well as for the Linux systems. So when you click on this download, so it will automatically download the best version that is suited for your system. Okay, I'm repeating again. In the Google, you can search Weka. So you can see a link provided by SourceForge. SourceForge. So you can click on this link and then download. Automatically, the best version will be downloaded for you. So here. So here is how the Weka welcome page look like. So here you have options like Explorer, Experimenter, Knowledge Flow, Workbench, and Simple CLI. So first, let's start with the Explorer. So the Experimenter, Knowledge Flow, Workbench, Simple Command Line are the ones to use within installing within your system and using. So when you click on the Explorer tab, you get these options. So there are some already default files that are available, some model or example files. So to select those, one can click on Open File. So go to the location where your Weka has been installed. So my Weka has been installed in Windows C, Program Files, Weka 3.86 is my Weka. So we have data. So these are the set of ARFF format files that are available. So Weka initially has been developed only to access the ARFF format, but recent advancements of Weka also accept the CSV file. So you can see what are the file formats that Weka accept. So ARFF, C4 files, CSV files, JSON files, MATLAB files, SVM library SVM files, binary files, XRFF files. So here the examples are, so I'm selecting this breast cancer, for example. 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 So I'm selecting this breast So here I have loaded my data. When you closely focus on this, where my arrow is hovering, this gives us the information about your data set. What data set you have been loaded, that is breast cancer data set, how many attributes it has, that is how many columns it has, 10 columns, how many instances it has, that is number of rows, 286. This is sum of weights is tells us the uniqueness of the data. So under this you see each column, like first column is age, next third column is tumor size, we have menopause also here. So we have node caps. So when we take about the last class, so last class is what we are trying to predict, that is no recurrence event or recurrence event in a patient what we see. So this is how you can see we have 201 instances for no recurrence class, we have 85 for recurrence events. Now I wanted to build a machine learning model so that if at all, if I see any new data, I can classify a new patient, I can tell whether she can have a recurrence events of the cancer or a no recurrence of the cancer. So I'll be selecting the algorithm. So several algorithms. To select the algorithms, click on classify button. Now we are in pre-process. Now we are clicking classify button. Then we are selecting this 0 or some functions. So several functions are available. You can click on this arrow marks before to know more details. Okay, here selecting logistic regression only. Use training set option and then select. So here under summary section, we see the metrics based on which we can judge whether our model is good or not. First thing tells is correctly classified instances. So we have 218 correctly classified instances. That is, then we have incorrectly classified instances. So what happens here is, I'll show what is happening. Yeah. So it gives us information how our model is learning from the data. So and once model is learned, so in the first highlighted case, if you see, actual one is to be recurrence event, but the model learned it to be a non-recurrence event. So likewise, we have four options that could be generated. So we can have true positives that has shown here. So we'll have true positives, true negatives, false positives, false positives, and false negatives. So this is a confusion matrix that is given by Veka. So based on this confusion matrix, several metrics has been calculated. Here, one should remember that under this TP rate, you can see three values under TP rate. So first value is sensitivity, next is specificity, third one is accuracy. So this is how a simple model has been built. If I want to perform a cross validation on my model, under the test options, I'll be selecting a cross validation. Then I'll click number of folds. So I'll be selecting 10 folds as of now, then start again. So we have seen the metrics corresponding to the cross validation step. Similarly, select attributes can be performed. So under the select attributes, we have attribute evaluator and search method. So I'm not changing anything, I'm just clicking. So here, out of the 9 features that we are given, the select attribute methods tell these 5 features are sufficient for you to build a good model. So this is how a classification. Similarly, one can input a a regression dataset to perform the regression analysis. So this is what demo. So before moving on to the recap session, let's take up some of the questions. Please try to answer these questions and then we'll move on to the demo session, recap session, where I'll be taking up numericals solely. So here the first question is, in k-means clustering, k is meant for. So k-means clustering stands for number of clusters. So given the confusion matrix, try to calculate the sensitivity, specificity and accuracy. So here I am giving formulas, but make sure you remember the calculation formulas of these. So try to calculate sensitivity, specificity and accuracy. So sensitivity is given as true positives divided by true positive plus false negative. Specificity is given as true negatives divided by true negative plus false positive, and accuracy is sum of true positives plus true negatives divided by true positive plus true negative, false positive plus false negative. So whenever we are trying to solve a regression confusion matrix based problem, make sure to identify the columns that are showing your actual values and predicted values. See, two images here is having interchange of the columns. So in this case, true positives and true negatives won't change their position, but the false positive and false negative will change their position. So here we have 5 true positives, that is actually positive and predicted as positive. So we have true positives that are actually positive and predicted as positive. We have 5 true negatives that are actually negative and predicted as negative 1. False positive, that is that are falsely predicted as positives, we have 4, then false negatives we have 0. So sensitivity is calculated as true positive divided by true positive plus false positive. So which is 5 divided by 5 plus 4. Okay, this is how sensitivity. This is sensitivity. Similarly, specificity is given as true negative divided by true negative plus false negative. So here it is 1 divided by 1 plus 0, which is 1. Now which is accuracy is a balanced measure. So correctly predicted instances. How many correctly predicted instances we have? That is, we have true positives 5 and true negatives 1. That is 5 plus 1 divided by sum of all the predictions. 5 plus 1 plus 4 plus 0. That is 6 divided by 10. That is 0.6. Okay, sorry for the error here. I'll change it. So, given the specificity of a classification method as 0.75, can someone predict what will be the false positive rate? It is 0.25 because specificity is, so they have 1 minus 0.75. So how here we have achieved a false positive rate of 0.25 is 1 minus specificity gives false positive rate. So 1 minus 0.75 gives 0.25. So here I have few questions, 2 or 3 more questions on Veka before starting to recap. So what is Veka used for? Whether Veka can be used for regression, Veka can be used for classification, Veka can be used for clustering, or all of the above. Yeah, so Veka has inbuilt regression algorithms to perform. Along with regression algorithm, it also has classification methods to do, and we also have clustering methods. So the output of Veka provides information on whether Veka outputs a sensitivity value, or Veka outputs a specificity value, or Veka outputs a accuracy, or Veka outputs all. So Weka gives information about all sensitivity, specificity, accuracy. So these values are directly not mentioned. So these are available under TP rate column under the summary of Weka output. Okay. So before moving, so any questions on this week 12? If not, okay, I'll move on to recap. So here, so I'll be taking up all the numerical problems, possible numerical problems that can be that are previously taught. So okay, thanks for your answer. Okay. So first is, given if AT content in a DNA sequence is 20%, what is the GC content of the same DNA sequence? GC content in the same DNA sequence. I think it's pretty simple question to start with. Yeah. So it is 72% because the DNA is made up of ATGC content only. So if AT content is 28%, the remaining 72%. So both combined up to make it 100%. So here I have one more question. If T content in a DNA sequence is 12%, what is the AT and GC content in the same DNA sequence? Now I am not given AT, here it is only T content. Yeah. So it is. I got some answers. So given T is 12%. So we know A is complementary to T. So if T is 12%, A will be also equals to 12%. So both A and T make up to 12 plus 12. That is 24%. And then remaining 76% is GC. So this is the complementarity base pairing concept. So if a DNA sequence CG, TTA, GSC, see how many total number of hydrogen bonds would be there if we see a double stranded structure. So this is the sequence number of hydrogen bonds that is possible. So we all know GC base pairing has 3 hydrogen bonds, AT base pairing has 2 hydrogen bonds between them. So based on this concept, so this is the given sequence. So here we have C, which can form 3 hydrogen bonds with G. We have G, which can form 3 hydrogen bonds with C. We have T, which forms 2 hydrogen bonds with A, 2 hydrogen bonds with A, again 3 hydrogen bonds with C, 2 hydrogen bonds with T, and 3 hydrogen bonds with G. So if you count 3 plus 3 6, 3 plus 3 6, 6 plus 2 8, 10, 12. So we have 3 plus 3 plus 2 plus 2, 3, 2 plus 3. So which is like 6, 10, 20. So 20 hydrogen bonds. So here are for some numbers. How many peptides are needed to code for a single amino acid? So this is from codon table. Okay, so we have combination of 3 nucleotides that code for a single amino acid, that is a codon. So how many different codons are there in the genetic code? So we have 64, that is we have 4 nucleotides. If we place them into 3 positions, 4 power 3, that is 64 different codons are possible. So how many codons code for amino acid? That is 61. But what is happening to remaining 3? What are those? Yes, thank you for your answers. Remaining are 3 stop codons. So where once encountering a top codon, the translation of a protein will stop. So here we have studied about global alignment. So global alignment is comparing a type of comparison between two sequences from one end to the other over whole length. So here I have given a matrix which I have initiated and I penalized with a gap penalty, that is initialized with 0, then have applied this gap penalty throughout this matrix. Now these are the conditions we have. So when we are moving from horizontally or vertically, we subtract with the gap penalty. But when you are moving diagonally, we either can consider match or mismatch. So here I have already a filled matrix given. Please find what is this question mark tells. What is this value? I have given conditions here. What conditions need to be applied? Use a match score of 8, mismatch score of -5, gap of -3. What would be the value of this question mark I am showing? So how to calculate I am giving here. So select score yes based on whether it's match or mismatch condition. So can someone tell whether here it's a match condition or a mismatch condition? So to check that, check what is the amino acid corresponding here and amino acid. So it is T on one side, A on other side. So it's a mismatch. Okay, so here it is given. So this is the condition that we have. So I want to calculate the value of the box. So this value can be derived from three places, that is horizontal, vertical and diagonal. So here I'll try to add up the gap penalty, that is -3 and -3. So here we have one value of 0, -3, -14, -3, then a diagonal value. So since it's a mismatch, it is -5, mismatch score. That is -11, -5. So here overall we had -3, -17 and -16. So the maximum value of this is filled here, that is 3, -3 is the maximum value. So this takes value of -3. This is how a global alignment matrix has been filled. So -3. Okay, similarly we'll take up one local alignment problem. So the difference between local alignment and global alignment is we have an extra condition, that is 0. Here we don't consider negative values. Always if we encounter a negative value, we'll replace it with a 0. So given the alignment here, try to find what the value of this question mark corresponds to. Let's solve this. So we have here, so from here we get minus 3, from here we get minus 3, which is a gap penalty. From here it's a mismatch, so we had minus 5. So the conditions will be like 0, which is by default that comes in local alignment, that is maximum of, so 5 minus 5 0, 3 minus 3 0, then we have 10 minus 3 7. So here we can fill it with 7. It is 7. Okay, kindly provide the Newick notation for the given tree. So here, based on the nodes that are close together, they have been grouped. So first we see B and C very close. So the best way to build understand it, build a Newick format from a tree is move from the leaf nodes. So from this, so I wanted to move. So see, the first one that I encounter is BC, then DE. So I grouped BC together, DE together. Then I encounter A, which is very close to BC. So now BCA, then DE. So this is how we group. The best way to is move from the side of ABC towards the root node. Then it is very easy to build. So here I have given a peptide of sequences LEAD SEQ, and I have given the molecular weights here. So what will be the molecular weight of the whole peptide? So here when a peptide bond is formed, a water molecule is evaporated. So we need to subtract the number of times this water molecule has been removed. The molecular weight of water we have to subtract. Let's solve it. So here this is the sequence. So I have added the molecular weights here. So this sum of molecular weights will be 870. So I have added molecular weight of leucine. Uh, so here I have added the molecular weight of leucine, glutamic acid, alanine, aspartic acid, serine, E here. This is E. Then again I have added molecular weight of glutamine as well, that is represented by Q. So the sum of these molecular weights is 870 minus number of peptide bonds that could form into 18. So how many number of peptide bonds are possible for a peptide having 7 amino acids? Yes, that is 6. So this gives an answer to 762. So in general biology studies or bioinformatics studies, what is the average weight of one amino acid is considered as? Its weight is 762. So the average weight of one amino acid is considered around in between 100 to 110 daltons. So here, given a pattern, so identify a sequence which matches the pattern given. So here I'm giving you a hint what does the pattern tells for. To try to remember, in the exam hints won't be given. No. So here in the given pattern, X stands for any amino acid. So in the place of X, any amino acid can come. If a residues here ALT has been enclosed in a square bracket, that means at this position either A, L or T can be seen. So if we are using this flower brackets or curly braces, what we call, except these A and M, any amino acid can be seen in this position. And if the number is shown like 3 here, 2 here, it shows the repetition of the same condition. So here we have either P, L, A, so all of the options satisfies that condition. Then we have X, any amino acid, so we can't judge. Then we have G, so here the option C is eliminated now because in third position it has P. Then either of, in the fourth position, either of K or neither of K or P should be there. So in the first condition we have K, so it is eliminated. Now A and C are gone. Then we have K again here, so option B. So remaining we have option A. So it is D. So next question is what is the propensity of leucine to be in the helix? So the propensity value is calculated as percentage of residue I in helix divided by percentage of all residues in helix. So how the percentage of residue I in helix is calculated is number of residues of type I in alpha helix, that is denoted by H here, divided by total number of residues of type I in the whole data set. Similarly, the denominator value, that is percentage of all residues in helix, is calculated as total number of residues in helix divided by total number of residues in whole data set. So to simplify the question, I am giving here the counts. So number of leucines in alpha helix is 3, total number of leucines in sequence is 5, total number of residues in alpha helix is 8. Here, so first thing is propensity of residue leucine to be, percentage of leucine residues to be, so number of leucines in alpha helix is 3 divided by total number of leucines in the given sequence. Then percentage of alpha helical residues, that is we have 8 alpha helices in a sequence of 13. So here we have 0.975 when you solve this. So this is small n alpha term is given, and that this is capital N alpha term which is given in the formula. So I used, so it comes around 39 divided by 40, which equals to this. So the answer is 0.975. So here I have given IC50 values of two protein ligand complexes that are 15 nanomolar and 6 nanomolar, and the IC50's values are related with hydrogen bond donors, that is 4 and 3, and polar surface area of 3 and 4 respectively. So what will be the regression coefficient of hydrogen bond donor, regression coefficient of polar surface area, and IC50 of the component with 3 hydrogen bond donors and polar surface area of 3. So you need to form equations here. So let these be the equations, that is 15 equals to 4x plus 3y, So this is a similar problem that what we have solved during the class. So here the given equations are 15 equals to 4x plus 3y and 6 equals to 3x plus 4y. So I try to solve them. So I multiply equation 1 with 3 and 2 with 4. So this gives me like 45 equals to 12x plus 9y. Then this gives me 24 equals to 12x plus 16y. Now when I subtract these two, so 12x will get cancelled. So I'll be having 21 equals to minus 7y. So therefore y equals to, this implies y equals to minus 3. So if I substitute this y in the equation 1, it will be like 15 equals to 4x minus 9. So x value will be 24 divided by 6. That is, sorry, 4. 6. So we have known that the values here are, so x equals to 6 and y equals to minus 3. So what if the value of IC50, if we are having 3 hydrogen bond donors and 3 surface polar area of 3, what will be the IC50 value? Now we know the equation is y equals to 6x minus 3y. So given the equation, what we have built is 6, sorry, this is IC50. IC50 equals to 6x plus minus of 3y. So here we have got x equals to 3 and y equals to 3. So IC50 of the new compound is 6 into 3 minus 3 into 3. That is 18 minus 9, which equals to 9. Yeah, so the regression coefficient for hydrogen bond donor is, yeah, now we can answer it, okay, solving. So the regression coefficient for hydrogen bond donor, what we have observed is, what is the x value when we solve for x value? So x value we solved for is 6. So what is the regression coefficient for polar surface area? So it is minus 3 and IC50 value is 9. So any question on this solving, yeah, do ask, because these kind of questions are important. Similarly, I have given some other question. So one can form the equations and solve. So please let me know the answers. Solve these two equations for x and y. Yes, so the regression coefficient for hydrogen donor is 1, that is x value. Regression coefficient for polar surface area is 2, and IC50 value for the compound with 3 hydrogen bond donors and polar surface area is 9. So how did one can solve this? Here. So initially I multiplied this equation 2 with 2, then I got this new equation, then I subtracted this equation from this, so I got y value as 2, then I substituted this value in any one of these equations, I got x value as 1. So the final value equals to IC50 equals to x plus 2y. So here x we have given as 3 and y also 3 polar surface area, so which equals to 9. So given a confusion matrix, to try to find the model has, so find true positives, false negatives and true negatives. So here true positive is the predicted value is positive and it's actually it is positive. False positive means the predicted value is positive but it's actually a negative, that is false prediction, that is falsely predicted as positive. False negative means the predicted value is negative but it is positive, that is falsely predicted as negative. True negatives are like the predicted value is negative and its actual value is also negative. So consider in the given confusion matrix, spam as a positive class, Find number of true positives, false negatives and true negatives. Yeah, so the model has true positives 50, that is first. Then we have false positives 10. Then we have false negatives 20 and true negatives 20. So these are the formulas for sensitivity, specificity and accuracy. So based on this, so if a binary classification model has 90 true positives, 10 false positives, 5 false negatives and 985 true negatives, what is the model accuracy? So the accuracy is calculated as true positive plus true negative divided by true positive plus false positive, true negative plus false negative. So which we have 0.985, which are rounded off here. So how the accuracy is calculated in a multi-class? So given a multi-class classification model that has correctly classified 70 samples out of 100 samples, what is the model's accuracy? So number of correctly classified instances by all the instances gives. So here 70 divided by 100, we have accuracy of 0.7. So here all of these techniques, even cross-validation, can helps us to identify overfitting. So if a model is performing so good on our training set and if the model is not performing on cross-validation, any of the cross-validation, that is leave node cross-validation, 5-fold cross-validation, 10-fold, 20-fold, then it indicates it's a cross-validation and feature selection. So feature selection is very important in terms of avoiding overfitting or underfitting conditions. So here for the alignment of DNA sequence given below, what is the value of G at position 5 in the weight matrix? At position 5, what is the value for G in the weight matrix? So first identify So before solving this, I have a general question. So what would be the probability of seeing a residue in a particular position in case of DNA? So what is the probability of G? G I can see in DNA. In case of proteins, the 0.25 is correct. That is 1 out of 4. That is 1 by 4. No, it's not zero point 0.5. It is 0.05. That is 1 divided by 20. So first identify number of G's in position 5. Solve this. So here, for the weight matrix in a particular position, for residue, how we calculate is ln of n of ij, so number of times the residue that is observed plus probability of that residue to be observed divided by number of aligned sequences or number of positions that is available plus 1, this whole divided by probability of I again ln of this value. So here we get ln of, so we have G 3 times that is present plus 0.25. So we have 3 plus 0.25 divided by 4 plus 1 whole divided by 0.25 ln. So here we'll be having ln of 0.264 ln of 2.6, which equals to 0.955. So rounding of digits 0.96 have given. So similarly, one of our co-TA, Sunanda, has explained about how the calculations of this. So some of you might miss his class. So I took the same example here. So he has given how a alignment matrix has been filled. for each position, the frequency of values in aligned condition has been given. Followed by that, he used this formula to construct the weight matrix. So at each position, the weight of each nucleotide has been given, and he has explained it very well here. So I took the same example from him. So in the exam, we expect you to remember some formulas.
Sir, for this question,
Yes.
we can straight away only do the calculation for that A, G, G, correct?
Yeah. So
Because
straight
T
away.
is, T is 0, 0 plus 0.25 by divided by 5 into 0.25, which is equal to 1 by 5, log of 1 by 5. Are we supposed to construct all the weight matrix, align matrix, all these things, or just straight away we can do that?
In the previous example, I took only single question and I showed. Here I want to show how a complete weight matrix is constructed and how
Okay,
it looks like.
okay, thank you.
Okay. So here, when you consider it, just give me a second. So here n of ij is 0. So according to our thing, so is 0.25 divided by n plus 1, that is 4 plus 1, again divided by 0.25. So here 0.25, 0.25 gets cancelled. So we'll have ln of 1 by 5, which is equals to minus 1.6. So here I have showing experimental and predicted values. So in this experimental prediction, or experimental predicted values, B denotes for positive class and N denotes for negative class. So based on this, so find out number of true positives, true negatives, false negatives, and false positives. So true positives are nothing but they're actually positive and predicted positive. True negatives are they're actually negative. That is in experimental they are negative and predicted as negative. So in terms of true positive, we have here B predicted as B. So once you have correctly identified true positives, true negatives, false negatives, and false positives, you can calculate sensitivity, specificity, and accuracy. So here, the similar kind of question, I made it into a conceptual. So in a protein DNA complex, with 150 amino acid residues, 30 residues are binding site, and a prediction program identified 40 binding site residues and 25 are matching with experimental data. So try to find out false positives and false negatives in the above condition. Yeah, once one identifies true positives, true negatives, and false positives, they can use the formula to calculate sensitivity, specificity, and accuracy. I just moved on here because I have 10 more minutes only for the session. Consider here experimental binding sites as positives. So since here given out of predicted 40, 20 are experimentally or 20 are matching with experimental data. So 20 are matching with the experimental data. Sorry, 25. So 25 are true positives. So remaining 15 which are predicted as positives but they are actually negatives are falsely predicted as positives. So we know total positives are 30, out of which 25 are correctly predicted. Remaining 5 are wrongly classified as negative. So this is falsely classified as negative. Actually, these 5 are positives but wrongly given as negatives. Then true negatives will be 105. Because total number of negatives we have 120, out of which 15 are wrongly predicted as positives. So remaining 105 are correctly predicted. 105 plus 50. So here I have given a representation in terms of W0, W1 and X1. So solve this SGN function and based on the condition given, answer the following. So what is the X value you got in SGN? Actually, I'm showing the answer here. Yeah, so here since W0 is 1.5 plus that is okay, we have this SGN plus 1 into 2. So we have SGN of 3.5. So which according to condition, if this X is positive, so the overall is positive. If for example, if we take SGN of -2, what will be the answer? If we take SGN of -2, what will be the answer? Yes, it is 0. This is an example I have given. So actual answer to this, the previous question is this. So this is end of today's class and for this year the class. Thank you everyone for attending the sessions. And if you have any questions, I can answer now. In this session, I tried to cover maximum numericals that are possible. If nobody is having the question, you guys are free to leave. I'll make sure the